The question is, the value of the following limit is, limit extends to 0 plus square root of x divided by 1 minus e to the power 2 times square root of x. This question is from engineering mathematics from the topic calculus limits. The solution is, so x tends to 0 plus means that is right hand limit at x equal to 0. This is our function. Since root x tends to 0 and e to the power 2 root x tends to 1 as x approaches to 0 plus. What is x tends to 0 plus means? This implies x tends to 0 as well as x greater than 0. X greater than 0 means 0.001 approximately 0 means greater than 0 means right hand side to 0, 0.001. So square root of 0.0001 is almost tends to 0. So e power 0 tends to 1. So therefore, this is 0 by 0 form. Okay. Limit x tends to 0 plus root x by 1 minus e to the power 2 root x. This is 0 by 0 form. So according to the L'Hospital rule, that is applying L'Hospital rule, that is differentiate numerator and denominator with respect to x. Okay. So root x derivative with respect to x 1 by 2 root x whole divided by 1 derivative 0 e power 2 root x derivative e power 2 root x into 2 root x derivative 2 times 1 by 2 root x. So this becomes 1 by root x using L'Hospital's rule. Now this is limit x tends to 0 plus 1 by root x, 1 by root x cancel. So finally this is minus 1 by 2 times e to the power 2 root x. So this is minus 1 by 2. E power 0 already 1. So this is minus 0.5. So the answer is minus 0.5. This is the end of the question. The question is, consider the following two statements with respect to the matrices A m cross n, B n cross m, C n cross n, D n cross n. This is n cross n. Statement 1, trace AB is equal to trace BA. Statement 2, trace CD is equal to trace DC, where TR brackets represent the trace of a matrix. Which one of the following holds? This question is from the engineering mathematics from the topic linear algebra basics. Solution. So here, A and B are not square matrices. Trace is defined for square matrix only. Trace of a square matrix is defined as sum of the principal diagonal elements. Okay, that is sum of the main diagonal elements. So A into B is of order m cross n, matrix multiplication. Okay. Similarly, B into A is of order matrix multiplication exists. Number of columns in the first matrix equal to number of rows in the second matrix. This is n cross n. C into D, n cross n. Similarly, CD and DC. Both C and D are already given n cross n matrices. So their multiplications in any order are also of order n cross n. So that means AB, BA, CD and DC are all square matrices. So we know that trace, TR stands for trace AB is equal to trace BA, properties. Okay, implies trace CD is equal to trace DC. So therefore, both statements are true, are correct. Okay, so that means accordingly option C. This is end of the question. The question is, which of the following is or the eigenvectors for the matrix given below? 4 by 4 matrix given, 4 options given. This is from engineering mathematics from the topic linear algebra, subtopic eigenvectors. The solution is so here eigenvalues lambda not given. Let us denote this is the matrix A. Okay. Let A be the given 4 cross 4 matrix and lambda be an eigenvalue of A. Since lambda value is not given, lambda values is or not given, therefore go by options method, or you can find characteristic equation all lambda values like that. Denote the each vector in each option by x whichever satisfies A into x is equal to lambda into x. This A into x is equal to lambda x. This is the procedure for finding eigenvectors. That is slash R is the required eigenvectors vectors of the matrix A. See, let us see the option A. So this is your x. Similarly, this is x. This is x. This is x. So A into x. First multiply A into x. Then if that value is equal to lambda into x, but lambda value we don't know. So in that A into x, after getting that answer, if you have a number into x, definitely that number is denoted by lambda, which is an eigenvalue of the matrix. So that is by one method. Okay. So if you do not get no real lambda, no such a lambda exists. That is. So Ax equal to A is minus 9, minus 6, minus 2, minus 4, minus 8, minus 6, minus 3, minus 1, 20, 15, 8, 5, 32, 21, 7, 12 into the set. Option A vector x minus 1, 1, 0, 1. So you know matrix multiplication, which will be getting again a column matrix. 9 minus 6, 3, 0, and this is minus 4. So minus 1, Like that, second row into this column gives 1. Third row into this column gives 0. Fourth row into this column gives 1. So this column vector I can write 1 into minus 1, 1, 0, 1. 1 into any vector is that vector itself only. So it looks like, so this is finally your vector x. And this is denoted by lambda. So finally we arrived Ax is equal to lambda x. Understood or not? So in this case, 1 is an eigenvalue of lambda. So this implies x is equal to minus 1, 1, 0, 1 transpose is an eigenvector of the matrix A, one of the eigenvector. Let us check the other B, C, D options also in this way. So sometimes no real lambda exists satisfying Ax equal to lambda x. Okay. Statement B, A into x, A matrix, minus 9, minus 6, minus 2, minus 4. This is minus 8, minus 6, minus 3, minus 1. 20, 15, 8, 5. 32, 21, 7, 12. This into second vector is 1, 0, minus 1, 0. So again you will be getting a column matrix. First row into this column gives minus 7, that is minus 9, 0, plus 2, 0. Minus 9 plus 2 simplifies to minus 7. Like that, second row into this column gives minus 5. Third row into this column vector gives 12. Fourth row into this vector gives 25. So now what is lambda x? Here no number is common in all the 4 elements. So we cannot express this as lambda into x. So this is not equal to lambda into x for any value lambda. Okay. For any value lambda. That means if you give lambda is any number, that number into this x, you never get this minus 7, minus 5, 12, 25. Okay. That means no value lambda. Of course, these all are real numbers. You'll be getting real only. Satisfies Ax is equal to lambda into x. Okay, because here you are not getting any number. So in this, x is equal to minus 1 plus 1, 0, minus 1, 0, is not an eigenvector. That is 1, 0, minus 1, 0. Row transpose means column vector. Is not an eigenvector. E vector means eigenvector. Now let us take the C. A into x. So A is the given 4 by 4 matrix. Minus 9, minus 6, minus 2, minus 4. Second row, minus 8, minus 6, minus 3, minus 1. Third row, 20, 15, 8, 5. Fourth row, 32, 21, 7, 12. Now x, column vector, minus 1, 0, 2, 2. So this simplifies to matrix multiplication. First row into column, plus 9, 0, minus 4, minus 8. So this simplifies to minus 3. Second row into this column simplifies to 0, like that. Third row into this column simplifies to 6. Fourth row into this column simplifies to 6. Now in this, a number 3 is getting common. Okay, or 3 is getting common. Don't take minus 3. because we should get again x column this vector. So to get -1 in the first element, let us take 3 common, which is also common for all the elements. So -1, 0, 2, 2. So this column vector -1, 0, 2, 2 is nothing but the option C vector, and this 3 is nothing but a number lambda automatically. So lambda, that means 3 is also an eigenvalue of the same matrix, implies x is equal to -1, 0, 2, 2. Transpose is an A vector. Okay. Now option D. A into x is equal to, again A, -9, -6, -2, -4. This is -8, -6, -3, -1, 20, 15, 8, 5, 32, 21, 7, 12. X -1, 0, 2, 2. So multiplying these, we will be getting a column matrix. +9, first row into column, 0, -4, -8. So kindly excuse me. This D vector is 0, 1, -3, 0. The option D vector is 0, 1, -3, 0. Now check. First row into column. -9 into 0, -6 into 1, -2 into -3 plus 6, -4 into 0. So -6 plus 6 simplifies to 0. Like that, second row into this column simplifies to 3. Third row into this column simplifies to -9. Fourth row into this column simplifies to 0. So this is our x, base x. So you have to get base x after taking a proper common number. So I can take here 3 common. 3 into again 0, 1, -3, 0. So this is again your option D vector x, and automatically this is lambda. So here lambda is repeated 3, 3. 3 is repeated 2 times. For a 4 by 4 matrix, you have 4 values of lambda. Okay, already 3 values, 3, 3. The first one is, you know that lambda value 1. So implies option D is also, that is x is equal to 0, 1, -3, 0. Transpose is an E vector of the matrix A. Okay. So like that, this is also E vector of matrix A. Okay. So finally, A, C, D. Correct or not? So that's why they are asked which of the following is or the eigenvectors of the matrix. So therefore, A, C, D. Okay. Options A, C, D is the required answer. That is this one, this one, this one. So this is end of the question. The question is, consider solving the following system of simultaneous equations using LU decomposition method. X1 plus x2 minus 2x3 is equal to 4, x1 plus 3x2 minus x3 is equal to 7, 2x1 plus x2 minus 5x3 is equal to 7, where L and U are denoted as L is equal to 3 by 3 matrix, U is equal to 3 by 3 matrix given. L is a lower triangle matrix, U is an upper triangle matrix. So which one of the following is the correct combination of values of L33, L32, U33 and x1? So this is from engineering mathematics, from the topic either numerical methods or that is linear algebra. But this is for CS stream, it is linear algebra related question only. So this is LU decomposition method. So we require this L32, U33, L32, U33 and x1. So that means first we find L32, U33, then based on x1. Okay, whether we find value of x1 or not, that will depend on options. So According to LU decomposition method, either we take lower triangular matrix diagonal elements are 1 or diagonal elements of upper triangular matrix equal to 1. But here, in all the options, the third diagonal element of U, that is U33, is not equal to 1. Okay, so that's why they have taken, that means we must consider the lower triangular diagonal elements equal 1. So that is for convenience, take L11 is equal to L22 is equal to L33 is equal to 1. That is diagonal elements of lower triangular matrix L are equal to 1. U is an upper triangular, L is lower triangular. Okay. Now, after that, let the decomposition method is A is equal to L into U. What is that A? Coefficient matrix. Okay. So that is from the given system of equation, A is the coefficient matrix. So coefficient matrix means in all the left hand side of the equation, the coefficients of x1, x2, x3 considered collected in a matrix A, which is a square matrix. So this A is equal to 1, 1, minus 2, 1, 3, minus 1, 2, 1, minus 5. L into U. So in the previous slide, this is L is given, U is given, but instead of the diagonal elements of L, we have to take ones. So this is coefficient matrix. So this L is equal to lower triangular matrix means elements above the diagonal 0, upper triangular matrix means elements below the diagonal 0. 1, 0, 0. This is L21 entry 1, 0. This is L31, L32, and this is 1. And these upper triangular elements U11, U12, U13, 0, U22, U23, and this is 0, 0, U33. So right side matrix product, first row into column, U11, first row into second column, U12, first row into third column, U13, second row into first column, L21 into U11, second row into second column, L21, U12 plus U22, second row into third column, L21, U13 plus U23, next third row into first column, L31, U11, third row into second column, L31, U12 plus L32, U22, next third row into third column, L31, U13 plus L32, U23 plus U33. So two matrices are equal means corresponding elements are equal. From this, U11 is equal to 1. Second element, U12, that is also 1. Third element, U13 is equal to minus 2. Next, fourth element, L21 into u11 is equal to 1. From this, L21 is equal to 1. Next fifth element, L21 u12 plus u22 is equal to 3. So substituting this L21 1 here and u12 value 1 1 into 1, so simplifies to u22 is equal to 2. Next sixth element, L21 u13 plus u23 is equal to minus 1. So L21 value 1, u13 minus 2, 1 into minus 2 minus 2, simplifies to minus 1 plus 2, that means 1. From this, u23 is equal to 1. Seventh element is equal to L31 into u11 is equal to 2. u11 value 1. So implies L31 is equal to 2. Eighth element, L31 u12 plus L32 u22 is equal to 1. So L31 value 2, u12 value 1. 2 into 1, this is 2. So 1 minus 2 minus 1. And u22 value 2. So that is u22 value becomes minus 1 by 2. That is L32 value. Because u22 value 2. From this is the value L31 into u21. u12 is 2. L32 we don't know. u22 value 2. So u22 value now becomes, sorry, u22 value 2 given, L32 value we are going to find. This is 2. So L32 is equal to minus 1 by 2. Next, last element, L31 u13 plus L32 u23 plus u33 is equal to minus 5. So L31 into u13, u13 minus 2 into this 2 minus 4, L32 minus of, and u23 1. So this simplifies to minus of. So this is minus 4 plus to the right side become plus 4 minus 1, and this plus of minus of. So finally u33 will be giving minus half. Okay. So from this, what they're asking, L32 is equal to minus of u33 is equal to, this is also minus 1 by 2. Now let us see these two. So these are the, here L32 u33, this is wrong. L32 2 wrong. L32 minus of, u32 wrong. L32 minus of, and u33 minus of. So not required to find x1 is equal to 0. Why? Because these L32 u33 are only in option D. Therefore L33 is equal to minus of, u33 is equal to minus of. So you can write here directly. Therefore, in option D, only we have L32 is equal to minus of U33 is equal to minus of. So not required to find option, X1 value. So accordingly, the answer is option D. If you are interested, that means L3 to U33, the same minus of belongs to one more option, then you go for finding X1 below. So this is the answer. Option D is the answer. Okay. Now see, I am giving the detailed procedure in writing in brackets. Here, what is capital X? It is a column matrix containing unknowns, variables of the equation x1, x2, x3, and B is equal to column matrix whose entries are the numbers on the RHS of the equations. That is 4, 7, 7. Okay. Now, AX is equal to B. That is given system. The matrix form of the given system of equations can be written as L into U, because A is nothing but L into U. X is equal to B. According to matrix multiplication is associative, this can be written as left side L into Ux is equal to Y. Okay. So, what is this Y? That is L into Ux is equal to B. This is B. Okay. So denoting this Ux is equal to Y, where Y is equal to Y1, Y2, Y3. Implies L into Y is equal to B. This is equation 1, where Y is equal to column matrix, some other unknowns Y1, Y2, Y3. So this L is a lower triangular matrix. You will be getting lower triangular system of equations. From this, converting to equations, you will be getting Y1, Y2, Y3. And this is Uy is equal to Ux is equal to Y. Okay. And U into X is equal to Y. Let us say this is equation 2. So I have taken this U into X is equal to AY, where Y is a column matrix. So this is upper triangular system of equations. Okay. So what first solve equation 1, you will be getting Y1, Y2, Y3. And then substituting that Y1, Y2, Y3 in equation 2. Then equation 2 converting to equations form, you will be getting after solving X1, X2, X3. So solving 2 first. Solving 1 first. We get Y1, Y2, Y3. We get Y1, comma Y2, Y3. Next, solving equation 2, we get X1, X2, X3. It is a long process. Okay. So that's why in option D only given that value is L3 to U33 logically. So not required to solve the entire problem here, because only in option D we got the answers. Okay. So in this solving two equation, first we'll be getting X3, then X2, then X1. That's why it's a lengthy procedure. Okay. If more than two options having L3 to U33 value, then definitely we solve completely the problem. So accordingly, the answer is option D. This is end of the question.